Друзья, привет. Очень классно, что вы пришли. Меня зовут Олег
Dear friends, hello. It's great to see you here. My name is Oleg. I'm the data lead for Positive Technologies, and I will be doing data engineering track for you today. We have 7 presentations with very good speakers. My first speaker is Vladimir Ozerov.
Прежде чем мы начнем, очень важный
And before we begin,
бот
a
для
very important topic, number 1, is the questions bot.
Мы вопросы будем из бота зачитывать.
After each presentation, we will be reading the questions from this bot. And the second thing is we will need to assess your feedback, so please do leave feedback. Hello, dear colleagues. We'll look today at the data analysis tech. We know that the new technologies are appearing and disappearing in this area, so I'll do my best to share my opinion on why this all happens, and will do my best to refer you to the new announcements, technologies, and all the things that are going on. We will mostly focus on analytical database systems and rather than AI. I'm doing distributed SQL for the last 10 years, and we are creating a big project for data analysis for Russia. The sound is not very good, right?
Раз, все отлично. Хорошо, коллеги.
1, 2, 3? Yeah, good.
Поговорим про судьбу MPP.
So we will talk
Посмотрим
about massive parallel processing,
данных, больших данных. Мы интегрировали
have a look at big data and data lakes,
lakehouse и
computer storage, lakehouses,
современные тренды, это small data и
and a little bit of the modern trends like small data and composable database systems. I hope that this will give you a full picture of what's going on. So let's feel the vibes,
И тут вот интересно, можно посмотреть на paper от коллег.
especially the start of 2000. Microsoft colleagues from
Вопросом, что есть вообще большие
95 asks a question of what are large databases. Big data was not a popular term at that point in time. And what are the tasks?
установки SAP. Типичный размер базы данных какой-то.
For a typical SAP installation, it will be 200 to 300 megabytes. Some crazy guys will maybe have 10 gigabytes and even aim for a terabyte size database. And Walmart with Teradata was having a terabyte loads. And of course the question is, what do we do with this all? And the answer was to increase the amount of parallelism and interoperability between the components, and of course using the calculation power, compute power of different nodes and different parts of the chain. So we see that nowadays we've come to this. If you look at the trends of what's going on with the data, you see the growth of about this trend. We look at 2006 and onwards, but of course the size of data generated is getting bigger and bigger. And of course we need new technologies to process that data. Teradata is from a paper from 2001, but in reality they have the same picture from the 80s. And this architecture, starting from the 80s, was enabling massive parallel processing, working with data chunks, and because this is an appliance, they have very good interconnect. It's called BiNet. And what's more, they actively thought about reliability, and they have a thing called click. And if one of the nodes connected to all the nodes, and if one of the nodes stops working, then the other node will catch up and do the job. So those hardware and software stacks working together were very popular, and Netezza in about 2003 was also working well in that time, and they were very good at filtering, aggregation, decompression, and other tasks. Later on, they were purchased by IBM, and now we don't know their fate. Oracle, of course, with their Exadata.
И в своих маркетинговых материалах они, в общем-то, очень хорошо
2008,
преимущества использования паков.
they were showing the advantages of packs.
Такую систему для массивной обработки данных.
They said, of course, you can create such a system for massive data processing yourself, but setting it up, debugging it, making it work, it's very hard.
Достаточно активно.
And
в целом, те преимущества, которые не упоминают, сохраняются и по сей день.
the advantages that they had are still true. Even when we come with our technologies to run the pilot, we have the same issues, either slow hard drives or slow interconnect. So the packs would be the ideal solution for solving that issue.
Недостатки, когда вам нужно огромное количество денег отвалить заранее, да, и не все.
Then parallel with pack development, when you need to spend a lot of money upfront, there was a number of players trying to organize big data processing on a commodity equipment. In that sense, we had Metapa and DDR, DDR, based on Postgres, that evolved into Bizgres and later on Greenplan. And their goal was announced as creating a product that is possible to use and aimed at using the commodity equipment. And if
примерно в середине 2000-х стала еще одна проблема, связанная с тем, что
they were previously
вычислительная мощность процессоров
focusing on massive parallel processing,
стала выражаться
then the new problem arrived.
роста.
The processor power stopped growing and frequency stopped growing. So
чтобы как-то более эффективно использовать
the question of what can be done to more effectively use the CPU resources,
MongoDB, который я на слайде не показывал,
we
Systore,
found
Stonebreaker его
MongoDB and CStore papers
радикально пересмотреть подход к обработке, ну, там, условно,
that radically rethink the big data processing
по сути,
and suggest the idea of
данных, для которых характерны преимущественно чтения, будем использовать другое представление.
big data processing that it is mostly read.
Данные в колонке,
We use different representation of data because if you store the data by column rather than by row, you can use the parallelism of the processor, which is impossible when you
мы практически в это же время
use the raw-based format.
продукт, который называется Vertica. Вот, ну, я
Then
не сказал,
there was a product called Vertica created based on CStore.
да, там, или анонса, да,
By the way, on top we have years of the paper publication, and of course the products usually start to be created earlier, like Vertica. It was issued, shipped at 2005, 2007, and CStore was able to implement column storage and was aimed at reading big data sets.
Ну, по сути, говорила, что мы хотим быть продуктом,
Vertica told the market that they want to be run on the
на основе вот этих идей Systore
commodity hardware.
мы получили
So CStore and MongoDB were used to create a column-based
мы говорим про колоночную обработку,
database that is used
колоночные форматы.
currently from Greenplan to packs and is quite successful.
Увеличивалась
Also,
оперативной памяти, которая
every year, the memory capacity that you can install on the servers was growing, and that led to some interesting ideas. Like in 2010,
Hi-Rise, который
we had HiRise research system,
в общем-то предложить
where the researchers have attempted
под нагрузки, характерные для аналитики. Вы используете
a
колоночные
processing method
под
that uses column-based representation
представления.
for
Вот, и что интересно, они
big
это
data
сделали,
processing,
очень
and
такое
for
интересное
traditional laws,
предположение,
you keep
что
the
в
raw-based.
будущем счета,
And the assumption they
которые у
made,
вас есть, будут влезать в память. Поэтому свое
they
решение
thought
они проектировали с того, что вот
all the data will fit in the memory.
в памяти у нас и остаются.
So all
Дальше
the
на основе
columns will
Hi-Rise
stay in memory.
был проект Сабхана.
Then,
Ну, они
based
пишут
on
кодовую базу Hi-Rise, они не
the
используют, но, в
high-rise,
общем-то, это там
SAP was created.
очень тесно работа этих команд.
They
И
said they don't use high-rise
Hi-Rise появились в Хане. И
code,
Хана, в общем-то,
but
явно
many ideas from high-rise migrated to HANA.
Ну, у нас есть анализ данных,
And then they said that on the one side, they have data analysis, reports, and things that are important to the management. But at the same time, if we use aggregations for those reports, that then often
поэтому они говорят,
we don't have enough depth
в нашей системе вы
to
можете
dig deeper into the info
обработку и
we need. So they said you can use our system
процессинг.
for analytical processing and OTP
В
processing.
середине десятых годов
So by the mid
вендоров
2010,
вот в эти идеи HTAP.
a lot of vendors
Oracle — это Oracle Memory,
went that way.
Database in Memory, да, берем Microsoft.
So Oracle database in
В
memory,
общем-то,
Microsoft, they have their own
все
solutions,
они пытались отрисовать одну и ту же проблему, что давайте мы попытаемся
and all of them are trying to solve the same issue
организуем и
of using
обработку.
one
Потому что
software
с точки зрения
set
клиента, конечно,
to
различные
process both OLTP and OLAP,
тем лучше.
because the less moving objects, the less components you have in your infrastructure, the better. Did they succeed?
Не пошел.
I'm not sure.
Ну, может быть, где-то и
I
пошел,
think
потому
that
что глобально мы
it
все-таки
did not become mainstream,
специализированных систем. И вот
and that globally we see specialized systems used, even with Greenplum. The paper was published where they said Greenplum is an HTAP system.
В России там используют именно для HTAP. То есть
But let's see who is using Greenplum for,
ну,
the transactional processing.
да, мы все-таки говорим о том, что
Not too many companies.
Postgres там, или Oracle.
Mostly we would use Postgres
Мы уже гоняем аналитическую
or
обработку.
Oracle,
Вендора, конечно, могут говорить,
and Greenplum would be used for analytical processing. So the vendor would say one thing, and the reality would be different.
обработка.
Analytical databases and transactional processing would be two different things for many years, and even in Russia, we still have vendors trying to do HTAP
Очень сильно верят в этот кейс.
based on OMDB, and I keep in touch with that team, but whether they will succeed or not,
Так и не
I'm not sure, because for many big vendors, this approach of going mainstream did not lead to success.
середины 2000-х
And the big trend also is
Oracle
something that started in
одновременно вышли
around 2000, was Oracle launching
и анонсы запускают EC2. Вот это
WS and Amazon launching EC2.
очень эпохальное событие для всех,
And
потому что по большому счету они сказали,
that was
теперь
a
у вас есть
big event for all of us, because what they said was,
которые вы можете
now
реализовать по
you
мере
have unlimited computer storage that you can rent
аренды ресурсов
based on your demand.
очень быстро. Это, конечно,
That
было колоссальнейшим
capacity to
но
rent the resources
они,
was a great breakthrough.
Amazon, там Google и так далее,
But besides giving us those resources,
свои
those companies,
где они имеют предсказуемое для себя оборудование. И это позволяет им строить очень интересные
they have very well predictable equipment demand, and that allows them to build,
Здесь они
to
говорят,
create interesting solutions. So this is a paper from Amazon for Redshift, where they say that by building this product, we did not aim to
MPP и прочего, вместо этого
compete with other MPP vendors,
огромное количество данных.
but we just see that as our clients have a lot of data,
В этом пейпере прям дают такой термин
and
dark data.
they don't do it.
Да, так, ну,
They
вроде бы вы можете пользу получить, но не получаете. И их цель была сделать так,
coin the term dark data that you can use, but
поэтому, в общем-то, они в
you don't usually use.
продукта взяли,
So
ну,
to
по сути, продукт
work with that kind of data, they took Excel,
но кроме того, что это
massive parallel Postgres, and
они еще добавили, во-первых, интеграцию с большим количеством
besides it being a classic MPP, they added a lot of services, and knowing how those services work,
административной
they took a lot of administrative work
строите систему
on their side. So if you build a green plan system on-premise, then you need to plan for the DR contour, for data replication, and other stuff. But the Amazon colleagues would say, no, you just put a checkbox in this place, and that's it. And it's a great power of the cloud, because instead of that administrative load, you just get very simple solutions. And unlike packs,
все сделали, просто используйте. Здесь эта идея такая же, только это все строится
the
на
packs would also be
железе, которое находится под управлением
solving all your issues.
облачных
Here, it's all built on the commodity hardware, but just managed by the cloud players, the cloud providers. So clouds became huge competitors for many others, both for Greenplum and Exadata and other players. So they changed the dynamics, but of course they still have their negative sides. You cannot predict the costs well, you cannot move all the data to the cloud because of sensitivity and confidentiality.
Не позволяют вам этого сделать. Поэтому, конечно, это не является ответом на все, но тем не менее,
It can be even regulation
можно строить на облаках. Это
prohibiting you from moving that data. But the systems that you can build using the cloud is definitely a new and interesting thing. And for many solutions, that's the only economical choice. So during that time,
систему мы увидели и подъем пак.
with massive parallel computing developing, we looked at the pack, we looked at the on-premise and the clouds. And one of the biggest issues those massive parallel systems was the scaling, because the more nodes you add to the cluster, the tougher the issues of moving the data. And that's why, at the current stage, the more data you have, the more expensive those products become for you. So, the question was, can we use some other approach? And it's a great time to move to data lakes. As always, if we look at the cost of the drives, whatever, SSD or HDD, the cost of 1 gigabyte or terabyte of information is going down constantly. At the same time, the throughput of the network is growing. So the question is, can we somehow organize the storage and computation in a more effective way? And in this sense, Google is an interesting player, because between 2003 and 2005 they published a number of fundamental papers. We understood they were fundamental only later on, one being Google File System, a distributed file system built on commodity hardware. Google File System was the basis for the HDFS project. And the second one was MapReduce, a computational paradigm on top of that disk commodity environment that allows you, by using MapReduce, on their workloads, they found that most of the computations work very well with that paradigm. Later on, we got Hadoop based on that. HDFS stayed, and MapReduce was replaced by Apache Spark. And what is interesting is that this is the first large-scale example of a product where the computation is separated from the storage. But at the same time, many companies started asking, whether they can simplify access to that data and add SQL there. And of course, Hive is an interesting product developed by Facebook. The paper was published in 2010. I think the first version of Hive appeared in 2007 or 2008. And the motivation to create Hive was high complexity of MapReduce usage. So the analysts would prefer to declare the computations they want to run, and instead of running those MapReduce jobs, they offered an approach using SQL-like language called Hive code to run those large-scale computations on top of HDFS and to hide the MapReduce complexity by the syntactical sugar of HiveQL. Then, in the depth of Facebook, Preston appeared. And the idea of Preston was that Facebook still wanted to launch SQL on top of their data, but they were not satisfied with the Hive response times, as Hive kept using MapReduce under the hood. It took a lot of time working with the disks, ensuring reliability, resiliency. So another approach was suggested: massive parallel engine that would not materialize, but stream the data between the nodes. Preston would go open source, Presto would go open source, then on top of that, there will be many vendors, including us, Amazon Athena, Starburst, and others.
Ну и, кстати, вы знаете, еще интересно отметить, что, например,
And an interesting point here is that in that Hive paper, Facebook says that one of the motivations for them to go HDFS and SQL on top was the fast growth of data that we had. In 2007, we had 15 terabytes of data, a small amount by today's margins, and then 700 terabytes. We started with some unnamed commercial vendor. I think it was an MPP under the hood that was not managing all the data well, and they moved to HDFS. And similar research was done by Google 2006 to 2005, maybe 2005. They launched the system called Dremel, and it was a SQL on top of distributed file system by Google. And they bypass using MapReduce under the hood, because the main idea of that system is interactive data analysis. So they changed the architecture to look very much like Presto, and Dremel would use in Bigware, commercial product by Google, Apache Drill, but the drill would give birth to Dremio project that is very popular in Russia and the West. And in Dremel, they described the column format of data storage that would support nested columns, and that would have the Parquet system built on. And all those systems enabled us to understand how can you create SQL on top of the data lake. And I think it's important to say that at the same time, the improvement of data storage was going on, and I think Parquet.org is the top format. And all those ideas were described in PAX format in the paper from 2001. It would have a fixed amount of records for specific row groups, but inside of those row groups, the data would be in column format. And those ideas represented in Dremel and starting in 2000, one Parquet.org was developed as a format for data storage on the drive, and at the same time, they would be very useful for MPP engines that would just go from the top. You can do very effective data skipping, and you would be able to read only, parts of columns or only ranges within the columns. So that's a great service. And the technologies were moving very fast. The last thing I would notice here is that the clouds were developing too. And the idea of computer storage was developed by Amazon. They evolved the Redshift inside of the company. Initially, Redshift was a shared nothing based system, but in about 10 years they separated compute from storage completely. So that idea of splitting compute and storage was really broad, and people started to apply it to different workloads. So based on the data lakes, we've implemented efficient storage formats. We were able to build cheap storage to separate compute from storage and give us nice interfaces like SQL or SQL-like engines. And it happened so that everything that was done by the data lakes was very much like what is done by the analytical systems like Greenplum. They can process analytics using massive parallel processing. They can process data in the column format. So they look very much alike inside. And an interesting question appeared. We need, on the one hand, to process data. Why would we need to duplicate that data? Can we get rid of it? And also the data lake issue is that many classical database services like transactions, schema evaluation, monitoring were lacking in the data lake-based system. So we are moving to the present time where we are trying to fill in this gap. So starting 2017, 2018, many tech vendors would start adding those components that we don't have in our analytical systems to data lakes, like transactions. The most often quoted is Delta Lake paper. And not only Delta Lake is important, we have Iceberg, which is most popular in Russia, Apache Hudi, starting 2017, and the formats have the same idea. Let's add transactions to data lakes. And some systems like Iceberg would say, well, a transaction. What is it? Let's remember how it works in Oracle or Postgres. Every time you change the data, you just add a new copy of the data. Can be differently organized, versioning can be different, but the essence is the same. And some process, a synchronous or asynchronous one, would be used. So those formats use very similar approach. You add new data, you don't touch the old data, and in some way you switch the pointer to the new version of the data, and you save the old data. There's a lot of ways to use it, like copy and write. You have a table, you have a file, or you just write the delta. So you can read both the original data and the delta and merge them. Something is good for reading, something is good for writing, but you cannot invent a universal format. And there's an interesting paper by Snowflake where they analyze the user logs that are there. We say that analytical systems usually read data, but in reality, customers would have a lot of writes, and this is okay. And this shows the complexity of creating that universal format that would fit everybody. So trying to apply the same rules to everybody would create issues. So both Iceberg and Hoodie goes mainstream. Delta Lake is pushing Databricks. Apache and Iceberg are pushing their products, but the idea is simple. We add new data, we control history and clean it up when we need it, and we just switch the pointers to the new version of the data. In the Delta Lake, they try to simulate in the lake itself. In Iceberg, they say, well, you need Hive Metastore or some database, but the idea is the same. An interesting point here is that if you add this technology to Market or Org, whatever you have something resembling the real database. But there's a lot of buts and limitations. Those formats are constantly improved, and I'm quite sure that they will continue existing and developing, because more and more vendors would put their bets on them. Like Microsoft, they use Delta Lake and Iceberg. Confluent, they used Iceberg. They adapt their product to directly write to Iceberg, and if you use Kafka to stream the data, we put them to Iceberg, and the data is immediately available for analytics. So big vendors would really bet on those systems. Moving forward, Databricks announces in a paper coining the term lakehouse, calling it something in between a data lake and a data warehouse. Of course, they push their own format of Delta Lake, but all modern formats will work as well. And an interesting question appears. How far can we push this approach? Because we understand that data warehouses are mostly at the top of their scalability. Top 100 companies of Russia would have the same issue. Green Plum clusters are very fat. It's hard to grow the resources every time you have you have gaps in service, you cannot move them to the cloud, you cannot. So you need to split compute and storage, because with that approach, you can grow your compute elastically as far as you want. But at the current stage, table formats are the area of constant improvement. There's a lot of things missing. Like you have transactions only for one table, maybe you need many tables. So not everything works, and the technologies are new. Sometimes they are green, not ready, but a lot is improving. And the vendors are looking attentively at the question. The move to lakehouse is good for the vendors creating data lakes, but not good for the classical nothing shared systems. And if you look attentively at the roadmaps or publications by different vendors, the strategies that they use would differ. Like you have Green Plum 7.
топят за одну и ту же мысль. Вот всю нагрузку, что у вас только есть.
Their whole presentation is about one thing. Give us all the load you have. Analytics, ML, everything. Text search, Solar, whatever. Whatever you can imagine. Put everything on our platform. My thinking is that won't work. Having everything in one product is not a successful recipe done by anyone. Sometimes cloud providers would succeed, but they succeed because they control huge data centers with a lot of products that they can reuse internally, and this works for them. Snowflake, Databricks, all the platforms, they would dominate in analytics, but to have that flexibility on premise is much harder. So when I look at Greenplum 7 announcement, I have a lot of questions. What are they doing? And we have other examples like Vertica. They are an on-premises vendor, and they do believe in data lakes or lakehouses. Maybe they had to, not that they wanted to, but they make specific steps in that direction. They announced vertical EON, computer separation of computing from storage. Now if you open Vertica, you would see that release to release, they keep adding things to Iceberg. So they work actively to take a very significant space in a market that is mostly supporting lakehouse ideas. So what will this bring us? Maybe Greenplum is right, maybe Vertica is right, but in my opinion, the idea of Vertica is better. Also, it's important to highlight that Arrow technology is rising. Where does it come from? Vendors mostly store in column-based format. Everybody does it in their own way, but mostly. We need to integrate a lot of products. And the interfaces for that integration would use raw format like GDBC drivers. So we have a situation where having some columns in one system, we would need to transform them into raw format and then back. So Arrow would suggest unifying the data transfer format. And they also suggest new approaches using new format instead of JDBC, ADBC, Arrow database connectivity, where they exchange columns, not the rows, or Light SQL patcher, a protocol that would allow you to launch queries and allow different systems to talk to each other. Like we implemented that in our product, and we can receive columns ourselves. So this leads to improved interoperability between the systems. More and more products are using this format, and it's a good idea to follow the development. It's a good question, how far will the lakehouses go? Many would say that it's the future, but many things can happen. But we separated compute from storage, then using Arrow, we are having more and more interfaces. And the next question is, how far can that decomposition of systems go? This defines many trends and technologies. A little bit of a side note. What's going on now? Day after day, we see iterative improvement in products, SQL format, all the aspects of how the systems work. Like recently,
Вышел там интересный доклад от Джулиан Хайда, это создатель
There was a great presentation, great paper by Julian Hyde,
понятие мер в
who
SQL.
suggests that we add a new measure format in SQL,
За счет чего
expanding the SQL syntaxes to merge the semantic models that we use for AI and merge them in SQL. So if you add some extensions to SQL, the need for semantic models in separate products would greatly reduce. Is it an interesting thing? Yeah, definitely. Those are just iterations. Or
А что-то за паркетом есть или нет?
we use Parquet actively. What is behind Parquet? What are those iterations that can improve Parquet? There's a lot of AI-based systems with vectors, embeddings, and other stuff. So maybe we can invent some format that suits this application better. So Lens format and Nimble format are the ones that are trying to solve the Parquet issues step by step in some small areas. Will they be able to win over the Parquet? We'll see. Those who create those solutions, they say it's a Parquet killer, but I have my doubts. I think those are just iterative improvements happening slowly. So follow the engineers on Twitter, and you'll know more about it. The active trends that we have in the scientific part of database development is the ability to split database. We've split the storage. Can we further split what we do? Compute. What is compute? So it's optimizing and then execution. Can we split them? One project would say yes, like watch that data fusion. It is an engine that helps you process the data in flow format. We will read the data from Parquet and give you back. If you want to create a separate optimizer, then it will be optimizing the request, and depending on the type of the request, you'll be able to send it to some other backend. So let's split the compute. And the situation that arises is that people promoting those projects would say, no, you will not have vendor lock-in. You will be able to reuse the engines by other vendors. But in fact, it's much more complicated because request optimization and execution are very seriously connected areas. So if you do the optimization, the system gives you good performance because their components are integrated, not because they're separated. So how far will they be able to progress is a big question. But still, there's some progress. The idea is, let's have a look at this engine or that engine.
Почему мы для каждой новой системы должны переизобретать велосипед? Давайте мы однократно этот изобретем, и вы будете его использовать. Вы используете именно наш велосипед.
Invent that bicycle once, but you will use only our bicycle, not the competitor's bicycle. And in this situation, fragmentation is hard to avoid because data fusion is written on Rust. And are you ready to support the engine that's built on Rust? I'm not sure. Apache Calcit is written on Java. Are you ready to work with Java? No, not everybody is. So it's complex, but the scientific community is boiling and not ready to support the idea of splitting everything and is pushing to split everything into very atomic parts. So for me, separating compute from storage is very simple compared to the issues that arise. And a very interesting trend that we also see is the attempt to classify the loads based on the size and send them to different engines.
мы там исследуем такие проекты.
We are researching
Это по большому счету
the
движки,
projects
которые в
like
рамках одной
HTAP and Polaris,
могут эффективно
and
данные в колоночном формате.
within one machine, they can process the data in column format. Why did they appear? Because as part of one server that you buy or purchase in the cloud, you can give this server a lot of storage and a lot of cores, especially if you have those resources as part of one machine. Then the workloads, the terabyte-sized workloads, will be processable within one server. So as soon as you remove all that distributedness, your reliability improves, your interconnects are not needed, so the data throughput improves. And you just take one big machine and for those buckets, green plums, dreams. Those distributed engines will be easy to solve. So people would say, yeah, we have 1 to 2 terabytes for DB. And MPP systems 10 to 100 terabytes. But if we go to petabytes, then an important question becomes whether we should use some specialized hardware for that. And Theseus, but by Valtron data, was announced, saying that we process the data using the GPUs, and it's at a petabyte scale, it gives a huge economic advantage compared to processing the same data based on Spark. To tell you the truth, their announcements have a lot of marketing BS, you know what I mean? But using the GPUs, the usage of GPUs was coined for data processing many decades ago, but you need to send the data to the GPU, so it's a heavy load of data transfer tasks that doesn't work well in smaller applications. So most vendors did not go to GPUs, and most of them have removed GPUs from their concept. But Voltron say that when you have petabytes of data that you need to process, then GPU starts to make sense. So small data, DuckDB, a lot of data, you have a different engine, and this all can be based on the same packet. And it's interesting that compute to storage separation helps you to change those engines whenever you need. Fragmentation or open engines will definitely happen, and let's follow that. So the last slide that I want to show you, if you have a look at the 1995 paper by Microsoft, the guys have forecasted everything. They saw that we will have more parallelism, that we will have many systems that you need to interface between each other. We'll have Arrow, we'll have not only the client, but the server processing power, and also the DuckDB, when you can do some part of the processing locally. So it's very interesting, and you do need to keep, in touch with what is going on and not lag behind. Thank you.
Спасибо большое. И обязательно сканируйте QR-код и оценивайте доклад.
Thanks much. Please do scan the QR code and ask questions. We currently have only one question, meaning we have one winner, HDFS and S3. Which chair would you choose? What is more interesting? Well, it's hard to tell. I think S3 is more future-prone than HDFS, because HDFS is a specific technology designed with some assumptions in mind that we will have blocks of this or that size, the big files, lake houses, and that's not so. Iceberg or data lake can create a lot of small files that won't work well with HDFS. So HDFS will keep surviving, but I think S3, which is a set of products under one interface, would work better to suit to your specific needs. Do we have any questions from the audience?
Здравствуйте, спасибо, очень интересно.
Hi, thanks. It's really very interesting and very well thought through. I'd like to know your opinion, because you touched pretty much everything, about medium-sized, a small-sized company, or a big-sized, huge company. What is your understanding of the tech stack that is optimal and future-proof for, adapted for growth? Well, unfortunately, the product we are aiming our Cypress data product at big companies, and we don't understand small companies too well. But the trends are, Facebook had 70 terabytes, and we thought it's a lot. But now 70 terabytes is okay for just any ordinary company. So most of the products I talked about in the Russian reality is top 100, top 200 companies. That's what we see in Russia. And for the smaller companies, this stack would be too complex. So clouds would be a great solution for them, because clouds solve a lot of your issues. You think less about the infrastructure. Small and medium companies can't afford this. Tooling-wise, for many tasks, the Excel will be a great tool. And having less and less data, you move to smaller scale. So I don't work there, and I would not be the right person to give my advice there. Okay, let me ask Vladimir a question. What do you think about those new Apache Doris, Star Rocks, and those new engines? Well, there's a lot of them, and they keep catching up with each other. It's hard to say which one is good, which one is bad. I like watching them in terms of marketing. Star Rocks, which, beats this one by a factor of 10, this one by a factor of 20. It's just for fun. It's not true. If you have different engines and you can measure them, in about a year, the picture will be different. All those engines are based on the same approach. Their peculiarities would differ, like index structures, but they keep catching up with each other. Performance-wise, I don't go too deep into them. Feature-wise, specific engines have specific features. We have a question from the audience. Dmitry is raising his hand. Hi, Vladimir. Great presentation. Papers, details. So if you send us a copy, it would be great. And we have a question. Where is ClickHouse? Well, there's a lot of products. And when I was preparing the presentation, ClickHouse is a niche product. We know we like it a lot in Russia and China, but in America, less so. So ClickHouse, Pino, they solve very specific tasks. Broad tables that we use for aggregates. But
хотя решают очень
For me, they're niche products because, yeah, they solve very specific tasks and issues. But
DuckDB.
Да.
Отличная идея.
we are looking at ClickHouse to replace DuckDB. Yes, ClickHouse has bought a startup, CH something, and they're going into small data. So I think it's a good idea. Yeah?
Последний вопрос.
Thanks.
Помимо GreenPlum 7,
One last question.
есть ли
Besides Green Plan 7, do you have
анализа данных?
similar
Я, наверное,
products
смогу как-то грамотно ответить.
to have data analysis
Пузыре варюсь.
as part of them?
На текущем этапе
Well, I'm in my own bubble, and currently, if you look at the worldwide trends,
то есть, знаете, там вот эти, там, условно говоря, там,
then the most
там Google, Microsoft,
universal
Snowflake,
set
Databricks,
of
вот,
different
они все предлагают прекрасно.
solutions would be in Amazon, in the clouds, Amazon, Microsoft.
Доминируют.
They would dominate.
Можем мы в России что-то такое построить? Ну, вот
Can we find something or build something like that in Russia? I don't know. Yandex has a lot.
там что-то появится.
DataPro, DataLens.
Такой коробочный
Maybe
продукт
they will
довольно сложно все-таки.
have something, but building a boxed product
Обычно свой
is a tough thing.